All right, class. Thankfully, the power just went out over at the field, football field, which was blasting music. So I think they must have blown a breaker or something. Anyway, let's go through this. I'm sorry. I did this once before and it died. I didn't record with the sound on. That's a common mistake I make. Makes me feel very frustrated. So this is going to go quick and fast because there's not really a whole heck of a lot. I got worried that I didn't have enough, that somehow I cut off some problems, but then I started looking at what I had and it's the right number. So this is the correct number of problems. All right, the first question is real easy. Let me just erase what I did here. First of all, circle the polynomial. The polynomial has only positive integer coefficients for x, no rational exponents, no fractions, and no negatives. So if you see a negative exponent, like on this case right here, it cannot be a polynomial. Our fraction, x to the 1/3, which can also be written as the cube root of x. So any roots would not be a polynomial. Negative exponent, if the variable's on bottom, it can't be a polynomial. It has to be on top. You could have 1/3 x squared plus 2x or something, but you cannot have the x on the bottom. All right, so the only one that's left is that one. All right, so the degree is 4. It's the highest power. In general, you start at the highest and work your way down to the lowest. So it's negative 3x to the 4th plus, oh my gosh, it's a good thing you didn't see it. That's not general form. General form is the highest power, then the next highest, and then the lowest powered. Okay. The y-intercept is always going to be, if it's a polynomial, the number added at the back end. So in this case, there is no number, but let's say there was a plus 5. Then the y-intercept would have been 5. But since there is no number, you can imagine that there's a plus 0. So the y-intercept is 0, and the point 0, 0 is on the graph. All right, to find the degree of a polynomial from a given set of tables, you have to do a bunch of differences. So we begin with the first difference, which is just you take the number on the right minus the number on the left. So negative 3 minus, sorry about that. So it's negative 3 minus 14 gives you negative 17. Negative 6 minus a negative 3 is negative 6 plus 3. That gives you negative 3. Negative 7. Negative 7 minus a negative 6 is negative 7 plus 6. And that's negative 1. 6 minus a negative 7 is 6 plus 7. That gives you 13. 69. Oh, come on. 69 minus 6 gives you 63. If all these numbers were the same, then because it was the first difference, you would say this was a linear function. It's to the first power. The degree is 1, but it's not. So we got to do the second difference. We keep going until we get to the final, until we either run out of numbers to subtract, in which case we just have to say it's not a polynomial, or we get to a constant difference. So now we're going to do the second difference is the difference of the difference. So negative 3 minus a negative 17 is positive 14. Negative 1 minus a negative 3, negative 1 plus 3 is 2. 13 minus a negative 1, 13 plus 1 is 14. And last but not least, 63 minus 13 gives you 50. Still not constant, so we go to our third difference. Okay. So now we go 2 minus 14 gives you negative 12. 14 minus 2 gives you 12. 50 minus 14 gives you 36. Still not constant. And since we still have 3 points, we can do we can get two differences out of there to see if they're constant, and it turns out they are. So the fourth time is a charm. 12 minus a negative 12 is a positive 24. 36 minus 12 is a positive 24. They are the same, so the degree is fourth, or the degree is 4. All right, so it's degree 4 or fourth degree polynomial. All right, find the x and y intercepts from factor form. Well, the x-intercepts are easy. It's just you take each factor, we've been doing this, and set them each equal to 0 and solve. So x minus 7 equal to 0 gives you 7. X minus 1 set equal to 0 gives you x equals 1. Notice I'm writing these as ordered pairs. You don't have to. You can leave them as just 7, 1, and negative 8. And the last but not least, x plus 8 equal to 0 gives us a negative 8. Okay. The y-intercept, all you got to do is put zeros in for x, because that occurs at x equals 0. And you end up with that product. 3 times a negative 7 times a negative 1 times 8. Using a calculator, you get 168. Okay? And that's the y-intercept. So the y-intercept would be 0, 168. All right. General form. Literally. There's the answer. But literally means you have to multiply. So I always start with x minus 7, x minus 1. You can do FOIL, or you could do the box. I did the box here if you wanted to look at, but you guys should know how the box works. I'll just FOIL it because it's easy to FOIL two binomials. So x times x gives you x squared. Negative 7, x times x gives you x squared. X times negative 1 is negative 1x. Negative 7 times x is negative 7x. Add those up, that's negative 8x. Negative 7 times negative 1 gives you positive 7, and that's where this came from. Then I have to remember to multiply it by the x plus 8, the third binomial. So I did a box, and you should be familiar with this. Notice I put the trinomial across the top, x squared minus 8x plus 7. Down the side, I went x plus 8. And then I just filled it in. X times x squared is x cubed. X times negative 8x is negative 8x squared. X times 7 gives you positive 7x. Positive 8 times x squared gives you a positive 8x squared. If you're wondering why these are scribbled out here, because they add up to 0. One's negative, one's positive, so they just kill each other. And then 8 times a negative 8 is negative 64x, and 8 times 7 is 56. Add up everything, the 8x squares kill each other, you're left with x cubed. Then you have to figure out what 7x minus 64x is, that's negative 57x, and you're left with the 56. Then, I mentioned this in class because I did this in class for you guys. Remember, there was that number in front that was sitting here. That is now here. We have to distribute it. So we distribute it to all three terms, and this is your final answer. All right? 3 times x cubed is 3x cubed. 3 times negative 57 is negative 164. Use a calculator. 3 times 56 is 168. All right. Now, for question number 4, it says, find the maximum number of x-intercepts and turns. Then describe the end behavior using proper notation. It says proper notation, but I'm not going to hold you to that. Notice this is in standard form, so it goes highest power to lowest. The maximum number of turns, of x-intercepts, of zeros, will be the degree of the polynomial. Okay, so in this case, it's 6. All right, maximum number of turns will always be the degree minus 1. We write that as n minus 1. So 6 minus 1 is 5. And so the maximum number of turns will be 5. The end behavior only depends on the lead term. First of all, the sign of the lead term will tell you if it goes up or down to the right. So since this is a -4. It doesn't matter if it's a 4, a 1, a -1, a negative 0.0003. The fact that you're multiplying it by a negative on the lead power means it's going to go down to the right. All right. Now, because the degree is even, it's going to do the same thing to the left. So it's going to go down to the left. Now, what would change if the lead term was positive and everything else was the same? Well, that would just imply that it would go up to the right and also up to the left because it's an even power. Now, if the power was odd, then it would be doing the opposite. So in this case, if this was -4x and that was like to the 7th, then it would go down to the right because of the negative coefficient, but then it would do the opposite to the left and it will go up. All right? The last little bit, okay? Notice they gave you this space, okay? I didn't realize it, so I wrote it all right here. First of all, here's your factored polynomial. All right, state the x-intercepts of the polynomial, including the multiplicity. Okay, the multiplicity is the degree on the factor that gives you the 0. So we get x equals 8 because that's from this one right here, x minus 8 equal to 0. But since it's squared, it's a multiplicity of 2. Okay? And because it's squared or even powered, it's going to bounce off the x-axis. Okay? It bounces. It's kind of like this. Oh, my pen died. So I'm just going to talk about this. So at x equals 8, it bounces off the x-axis. At x equals -6, which is coming from the x plus 6 factor equal to 0, subtract 6, you get x equals -6. The multiplicity is 6 because that's the degree of the factor, right? It's raised to the 6th power. And that also bounces off the x-axis. Now, because it's a higher power than 2, when it bounces, it kind of hangs out on the x-axis for a little bit before it bounces. Whereas if it's a squared, it kind of does that. That would be like at x equals 8. It will do something like that. But because it's to the 6th power, it would be like more like that. Where 6, or -6 would be right there. And this is because of the higher power, it stretches out the bounce. Okay. And then x equals 2 because there's no exponent on it. It just passes right through. It's a multiplicity of 1. It's really screwed up right there. Mult of 1 passes through x-axis. All right? And that's when I was like, oh my goodness, I was supposed to write all this stuff down here, blah, blah, blah. And that's pretty much your quiz. And that's going to cover you 7-1 through 7-4. So good luck and good night. I'll see you Thursday.